Hello everyone. So in the last video, we learned uh, some examples how to solve a second order differential equation using undetermined coefficients. So if the non-homogeneous part, so first let us write the general form of a second order differential equation. Non-homogeneous. So suppose we have this thing and g of t is some e power alpha t or some polynomial in t or sine alpha t cos beta 3. So if gt is any of these things or combination of these things, we can solve by the method of undetermined coefficients. But suppose g of t is something else, not among these functions, then we can't use undetermined coefficients to guess a trial solution for yb and then solve the particular solution. So in that case, we have to use another method to solve the non-homogeneous part of the differential equation called variation of parameters. So I will describe in this video how to use this method of addition of parameters to solve the differential equation. Okay, so suppose the homogeneous part of this differential equation star has two linearly independent solutions, y1t and y2t, then the particular solution is given as follows: ypt equal to minus the first solution integration of the second solution times g of t divided by Wronskian of y1 and y2. So these are linearly independent, so Wronskian is not equal to 0, so you can divide by Wronskian plus y2 times integration of y1 times gt divided by Wronskian of y1 y2. It's dt here, dt. So this is the form of the particular solution. So let's highlight it. So here you can this wt is on skin of y1 and y2. Okay. So now let's take an example and see how it works. Okay. So suppose our differential equation is this thing, y double prime plus y equal to sec x. Now you can see this is our g of x here. So this thing, okay, so for maintaining the uniformity, let us write t only and bc. So this is our g of t here. So this g of t has does not fall into any of those known solutions, right? Which trial solutions we know. So we'll use the undetermined coefficient method will not work here, and we'll use the variation of parameters method to solve this non-homogeneous second order differential equation. Okay, so characteristic equation of the homogeneous part is r square plus 1 equal to 0, and we know the roots are equal to plus minus I. Hence, the solution of the homogeneous part c1 cos t plus c2 sin t. So this is our y1t and this is our y2t. So now let's quickly calculate the Wronskian. So the Wronskian of y1, y2, it's cos t sin t minus sin t cos t, cos square t plus sin square t, so it's 1. Okay, now by suppose this thing by 1 ypt minus y1, so minus cos t integration of sin t and sec t, right? So sin t times sec t dt. So denominator is 1, so we don't have to think much about it. Y2 is sin t, next is cos t sec t dt. So the first one gives, so sec t is 1 by cos, so it's tan t dt plus sin t, it's 1 dt. It's fine. So t sin t minus cos t log cos t. So this is our right. So hence the general solution of the differential equation is yt is c1 cos t c2 sin t plus t sin t cos t ln mod cos t. Okay, so to understand better, let us solve one more example and see what happens. Okay. Y double prime minus y, same thing, just to change this thing. So this thing can be done by undetermined coefficients. Still we will do by the method of variation of parameters, and let's see what comes. Okay, so from the previous thing, slightly change the characteristic equation is r square minus 1 equal to 0 implies r equal to plus minus 1. Hence y ct equal to c1 e power t plus c2 e power minus t. Okay, so e power t happens to be a part of the solution or the homogeneous part. Okay, so that was useful for the observation, was useful for the case of undetermined coefficients. Now let's see. So here this is your y1t, this is your y2t. So by the formula yt equal to minus y1. Okay, so before that let's just calculate the Wronskian. So it's e power t, e power t, e power minus t, minus e power minus t. So it will cancel 1 minus 1 minus 2. Okay. E power minus t times gt is e power t by 2 dt plus e power minus t integration of e power t by minus 2t. So this minus will cancel. So it's e power t integration of this will come out 1 dt plus, let's take the minus out, e power minus t by 2 integration of it over 2t dt. So it's t e power t by 2 minus e power minus t. Total will come outside by 2. So it's by 4 e power t by 4. So this thing comes out. Now general solution is y of t. So okay, so observe one thing. So this e power t by 4, there is some coefficient times e power t. So that is already a part of the yct. That is a solution for the homogeneous part. So we can write the general solution as c1 e power t plus e2 e power minus t plus t e power t by 2 only, because we can accumulate this constant 1 minus 1 by 4 into this c1 and rewrite our c1 as a new c1. That is not a problem. So this is our general solution. Okay. So I think the method of undetermined coefficients you understood, where undetermined coefficients fail, and also we learned how to use the variation of parameters in those cases. So the main thing is, so if you can find out two linearly independent solutions, y1 and y2 of the homogeneous part, you found out the Wronskian, and then you can just put into this form, this ytp. So most of the cases, this integration will make your life easier if gt is none of the standard forms like e power alpha polynomial or sine cos.